All right, we'll go ahead and start. I think it's past a little bit if people trickle in, is what it is. Hopefully you were here for a RAG workshop. Some of you might have heard of this before. We're kind of going to go into what RAG is and some of the tools you can use RAG with and talk about that. A little bit on me. I am a computer engineering student across the street at UAH. That's what I have been doing all week, so this is the first day I'm actually here, which has been fun. I am a security researcher over at a small business called Skinny Research and Development. It's the logo in the corner. We're a team of five to six. We mainly do government training and development, that sort of thing. I like coffee, music, audio equipment, board games, anything like that. That picture was the house I grew up in Nashville, the backyard, like 3 days ago. So snowstorm, we all made it, but here we are. So why RAG? Anyone know what RAG is? Like, let's get into that first. Yeah, Retrieval-Augmented Generation, which is a lot of big fancy words for something that is actually fairly simple. Retrieval-Augmented Generation is just a way to give our models better data and better context. Okay? What happened, and the reason why I kind of called this workshop RAG Revolution, is in the beginning when we had this like transformers architecture, this initial model come about, people were like, okay, this is great, right? It generates text that like sounds like someone talking, but most of the time it didn't know what it was actually talking about, right? Hallucinated, lied, everything else. And so as we find out, when you provide context to the model, or even better, you can give it the answer in the context window, it'll actually synthesize that information and output it to a user, right? Gives you better information. So big reason for RAG is just you get better answers. You get more context-aware, more accurate answers, depending on whatever you're working on. This is a workshop. If you guys have laptops connected to the internet, we're going to go over Notebook LM. To get there, and go to Google. Sorry for those of you that do not have computers. I will try and make this quick, but I did want to show off actual tools that you can use for free. This one does require a Google account, so just be cognizant of that. Let's see. Yeah, so just go to, let's see if I can make this bigger. Nope. Search Notebook LM on Google, and it's going to be this first link. This is essentially the like prime example of what a RAG tool comes to. Again, this is made by Google, so it's powered by Gemini in the back end. Actually, I think Gemini has an integration straight into Notebook LM now. They started to kind of combine the tools together. But this has gotten a lot better recently. If you scroll through here, you'll get a bunch of great information. Google always has pretty pages. So you just click Try Notebook LM, and you're going to get to this kind of a page. For those of you who have not used this before, has anyone actually used this before? A couple of you? OK, perfect. You seen it? Anybody recently, like last couple days, maybe? I don't know when there's some stuff in here that since the last time I've gone over this has changed and seemingly got a lot better. So excited to see it again. What we are going to do is we're going to go create a new notebook. Okay? Essentially, the whole point of this tool is to be a notebook, or to more realistically use notes, use whatever you provide it as context. There are a couple documents that we can go over. If you don't have your own local documents, your own websites that you want to use, there is a page called skinny, sknnyRD.com/downloads that you can go to, and there is a document, a PDF document on there that you can pull. It's a declassified report on Edward Snowden, for those of you who have heard of him.
It's 100% declassified. You're positive of that?
Yes. For any of the government people in here, Do not have a heart attack. It is declassified. You will notice on the front page everything is strike through. This was released a couple years ago, so.
So there are rules, and there are rules for people that work in the intelligence community stuff. So I was making sure.
Yeah. No. Trust me. Yeah, it would be a bad day. My boss actually said that it would be best to use this document just to see all the government people squirm. So. That's funny. He is also the one that made this beautiful HTML web page. Not a coder, by the way, but he did piece this together. So, but it is this. Let's see. Do you guys see a different? Yeah. This Snowden PDF in there. You click on it, you will see everything strike through. No heart attacks. Interesting report if anyone wants to go through and read it all. That's not the point, though. If you want to, you can use that. That's what I'm going to use as an example of all of this, just as we kind of go along. You can download that. Again, up here, when you start one of these notebooks, what you'll see is you can upload sources from the web, so you can just drop in URLs here. So let's say you're researching something, working on something, you can quite literally paste in URLs, and as long as you can get to it on a Google browser, NotebookLM can too. That's why Gemini and NotebookLM have gotten so good, is because it's Google, right? They've got all of that at their disposal. But arguably, to me, the more powerful thing about this tool is that you can add your own files. So these are files that you've made, files that your organization has. I don't recommend uploading anything that would get you in trouble. But yeah, you can upload any PDF, any other documents. I think there are different versions of this. So I'm on the Pro version because of just a Google Workspace, right? I think with the free version, you can upload like up to 50 documents. It's quite a lot. You get a lot of tools for free. But what you'll see over here is that it'll start churning on this document, right? So it is actually processing. For those of you who know what OCR is, it's actually reading the text out of that document. There is nothing in there, right? Like that is a scanned in document. So there's nothing in there that code can just grab plainly. It is all OCR. And the great thing about NotebookLM is that it's going to give you an overview of all your sources right at the top, right? So typically, like if you're working on a project or something, your sources, so like I do a lot of Bluetooth research. So if I'm looking for specifics with the Bluetooth spec or other things, I'll have a ton of Bluetooth documentation in there. It's going to give an overview. Hey, look, you've got different Bluetooth specifications in here, stuff like that. This is telling you that this was a declassified House Intelligence Committee report. I think the report was done, 2013. Edward Snowden, for those of you who don't know, leaked a ton of classified information, a lot. 1.5 million documents is quite a bit. The US government has spent a ton of money trying to recover from the damage from all that. But essentially, what you have in this tool is you have a chatbot down here at the bottom right. So this is same thing as ChatGPT, same thing as Gemini, anytime you want to use that. But now it has context aware, right? So it has your PDF, it can look through that, and it is going to give you answers about this PDF, more or less. We use the term chatting with your documents, kind of a misnomer, but it's a good way to think about it. You are actually chatting with the PDF. This is great, but I mean, quite frankly, any tool can do this now. You can upload a PDF anywhere and you can search it. NotebookLM, again, it's nice because you can upload like 50 of one thing and you can organize it. I kind of like it like that. The cool thing that NotebookLM is doing is this studio section. This is not really seen in a lot of other places. There are various aspects of this that you can find in other tools, but to see all of these in one place is interesting. These are ways that you can help analyze the data. So in here, right, you can get overviews, video overviews, quiz, slide decks. This is great for students because you can upload a bunch of like notes, materials in there. But generally, data tables, slide decks, infographics, they are all good. Some of these take a while. So if you start clicking on one and you click something like a video overview of this, It's going to take a minute, right? This is when you go get a cup of coffee because it will take a good second. It's going to tell you that too. And what you'll see is down here, it's going to add all of this. I'd like to note a few other features in here. Sorry, I'm going fast. We don't have a lot of time. And again, I'm going to try and get you all out before lunch because I'm not in the mood to get stabbed. That's not a dig on any of you. I get quite hungry. But yeah, up here at the top, you'll see a settings. So you can actually configure the tone of the chat. You'll see there's a default. Sometimes I find the default in here to be very formal and very like, kind of hits all the T's, crosses all the I's. It's not easy to read sometimes. It's very dense text. Learning guide helps. Changing it to shorter helps. You can even do this. So this will allow you to put in a system prompt, right? So you can tell Notebook LM to treat you like a third grader, right? And assume you know nothing. Very helpful. It's a great time. The other thing that you'll see up here is a lot of different, again, like I said, source analysis, I guess. They call it Studio. I don't know a better word for it. This gives you an option to generate a whole bunch of different things. If you have pulled this up on the side, if you have uploaded your own information, now's a great time to start churning through that as we go through this workshop. That way, if you have questions, you see anything later, you can see it. They have this thing called a mind map. I find this interesting. It'll actually break down like the content of all your documents into kind of different categories, right? This actually helps you form questions more so than anything else, right? So let's say you're going into something you have no idea about, right? Like something gets thrown on your lap, you're like, I don't know what this is. Upload documents, find web sources about it, throw it in here, and then all of a sudden you can start going, okay, you know, this review talks about background and employment, disclosures, impact and damage, committee findings, etc. And then you can click further through that, right? So if I'm curious about his employment history as an NSA contractor, I can go all the way down through that and see, okay, he was at Booz Allen Hamilton, Perot Systems and Dell, is that right? Perot Systems. Okay. And then had a systems administrator role. And then I can even click these, and it's going to tell Notebook LM to discuss that further, right? It's a way to explore the data further. Super useful, again, if you're going into something new. If you have uploaded documents that you're like, I'm pretty confident I know what everything in here is, not as helpful, but that's where some of these other elements come into play. So you'll actually see there's ways to generate slide decks, infographics, reports, flashcards, quizzes, etc. I have done this already in another notebook. That way we're not sitting up here and watching AI churn for an hour. Let's see. And you'll see I've gone through here and made a ton of different documents. One thing that I've seen, the slide deck, infographic, data table, those are all new. They're very helpful. So infographic will actually generate a quick little infographic page, right? Like let's say you need a one slide, right, to get out there. This is it. It'll show you different things, give you an overview. Super helpful if you're putting on an event, putting on something, right? Just generate a quick infographic. These are all downloadable, right? You can just pull them straight from Notebook LM, change them if you want to. I think most of them come out as PDFs, so edit over it, right? But that's helpful. The data table is also helpful. This isn't like great data to make a table out of, but it has, right? It did a timeline. So you'll actually see it gave an overview of different dates, locations, and then key events, right? Interesting. If you need tabular format, it's there. And then another thing is that I found super cool is these slideshows, right? It generates slideshows with actually fairly compelling graphics. I will say in here, all of the markings at the top are not crossed through, and I'm sorry to give all the government guys a heart attack. There's nothing in there, I swear, but that is the AI. I actually tried. So you'll see there's a second report in here. I tried on this one to get the custom prompt and say, hey, if there are portion or classification markings, strike them through or mark declassified somewhere. And it worked on the first slide, and then it kind of fell apart for the rest. So I do apologize. But yeah, just just be aware. There's quizzes in here, flashcards. I'm not going to go over those as much. I do want to go over some things I find absolutely freaky, which is this guy. I don't know. This is coming out of the
splints, and I broke both my legs jumping out of a plane.
It's the difference between needing.
It's a podcast, but these are two AI voices that are going back and forth and explaining what's happening. Okay.
It takes a mundane reality washing out of training and rewrites it into a heroic tragedy.
And this pattern
Where's
just
my mouse?
keeps going. The report gets into his education.
So you can actually use an interactive mode and jump into that conversation and then be like, I don't know that my mic's probably coming through the thing, but you can tell it and say, hey, I want you to explain something further, right? And so what you typically do is you'll do this play button down here.
You know the image. We all know the image. The wire-rimmed glasses.
And then
whoa,
join.
did someone just break the fourth wall? Let's hear it.
Can you explain that further? Nope. See, it's asking me for permission. What? Anyway, point in case being, it's freaky. I'm not a fan, to be honest, but if that's your thing, honestly, for a long car ride or something, go for it. It will also generate videos on a topic. So if you need to learn something and you're a fan of like content, videos, stuff like this is all AI generated.
You've probably heard the name Edward Snowden. You know the story, right?
What is it?
The NSA contractor who became a whistleblower.
Yeah, compliance
hailed
videos.
as a hero for
Well,
exposing
yeah,
government
I mean,
surveillance. But what if I told you there's a completely
Again,
different
completely
version of that
AI
story?
generated.
An official counter-narrative written by the U.S. government itself.
So it'll actually go through throughout here. Most of the time, these videos are just slideshows, slide decks. But we found this out earlier. If you upload images, so let's say you're going through and you're trying to generate a report on something, and you've got images, you've got whatever else. Notebook LM will actually pull those images into the videos, into the slide decks, into everything else. Yeah, like this. This is a cover page. So it just pulled that straight out of the PDF and put it in the presentation. It'll do that with images to make reports, anything for you. And again, this is obviously video, but with the slide decks, it'll export as a PNG. So say you don't like something, you can, or not a PNG, a PDF, so you can change it. I think it's cool. I think it's also very freaky, but it's there. I don't know if anyone has tried that before. Some of you guys that have used Notebook LM, does anyone actually use the podcast thing regularly? You've used it before? Okay. Yeah, I have tried to use it, but the few times that I have been through like electrical engineering stuff, and then you start talking about circuits over a podcast, and it doesn't work very well because you're like this resistor and that capacitor, and things don't work well. But it is very cool. It helps you learn a lot of information. This is Notebook LM. Again, this is a tool made by Google. Behind the scenes, everything it is doing is basically RAG. Okay? RAG helps us do data ingestion. It helps take anything. So again, what they're doing with this PDF is they're taking it, they're extracting all the text from it, and they are using it in a big database to help the context of the model. Again, you can upload PNGs, you can upload a bunch of stuff. It is very much a data ingestion platform in a sense. But that is Notebook LM. Does anyone have questions on this?
So you said you could load 50 documents in there.
Yeah.
And it would reference that. Is there any page limit?
To the document, there's size limits on stuff, is for sure. Like you can, it's like 50 documents or up to a certain size limit that you hit at some point. I'm not entirely sure what those numbers are, but at least again with the free version, if you're just doing a couple documents, I've never had issues with it. And then the pro version, I've never run into hitting any walls at any point. So it's fairly generous, I'll say. Any other questions? Yes.
So this could just be me, but I like to do a lot of vetting accuracy. So I guess with Notebook LM, do you have a verification process, or do you find that it's pretty good on its own and you don't really need too much?
I mean, I'll always recommend you verify information. It'll do these in-text citations. So if you ask questions, it'll actually in-text citation to the exact page it pulled something from. So if you hover over one of these document 1. Again, when you have more documents, it'll be like, okay, this was document 1, 2, 3, whatever it pulled it from. But that way you can go back and you can actually see the source directly that it came from. It'll also do source summaries. So if you have multiple sources and you need to distinguish the several different things, you can. Again, very powerful tool. I feel like it's not talked about as much as ChatGPT, other things. Again, all of this is powered by RAG, so I wanted to show it off as an example of what this kind of technology, this workflow does. Any other questions before I move on? In the back.
You may be moving on to it, but assume that you don't want to give your data to Google. How do you go about developing your own RAG?
Developing your own RAG, it is very easy. So the guy was in here before. Does anyone remember what framework he was using off the top of their head? So there's frameworks. Most of the time, it's easy to code. There's a tool called Anything LLM. I don't know if anyone's used that before. It is essentially like a local ChatGPT, and then you can download Ollama is a way to host models, right? If you want to talk about that more, or you can talk about that. Or we do train on that, so little business pitch. Notebook LM. So again, the main thing that powers it is RAG, but the core technology inside of RAG is this thing called vector embeddings, okay? It sounds scary, it's not. Vector embeddings are rather simple. Anyone heard of this before? Yeah, a couple of you? So vector embeddings is a really simple concept. So essentially, computers can't process images, they can't process words, right? Computers are really good at doing math, that's all they know how to do, so we have to change everything to numbers. Vector embeddings is a way to do that. So we can take nearly anything, so in this case an image of a husky, and change it to numbers, right? What do you notice about these? It's a vector. There's two, in reality, in this case, this is what we call a two-dimensional vector, right? So we have two numbers in order, and that's what we're converting our image of a husky to. With a two-dimensional number, we can also just plot it, right? We can say on a grid, hey, here is a husky. We know where that's at. Well, what we do is we keep doing this process with all the data in our sources. Okay, so if we have a golden doodle, we'll go through and we'll do the same thing. We'll make another number. Anyone notice something about these two vectors? They are very close. These two numbers are very close. Why might that be? They're both dogs, yeah, exactly. They are both dogs. So in this image, we have two dogs. They are close in space because they are close semantically. If anyone's heard that term before, it means they mean similar things, they have similar meanings, they're close semantically. Again, we can do it again. We just keep doing this over and over again with all of our sources. So that while Notebook LM was up there spinning on our Snowden PDF, right, this is what it was doing, is it was just breaking that document up and then making vectors out of all of it. In this case, we can take a cat and a car, and we can throw it in our vector space as well, okay? Anyone notice about the car versus the cat? Car's a lot further, right? It's not quite as similar to dogs as a cat is, right? Similarity, the easy way to determine similarity is, hey, how far are these 2 points, right? Distance, that is called Euclidean similarity, when you take the distance between 2 points. Another popular method for that is actually called cosine similarity, where instead of doing distance, you do the angle. The calculation's a lot faster, and it's I think it's actually more effective in a lot of spaces to take the angle between two rather than the distance. And we'll talk about why in a second. Essentially, after you've done this a ton of times, you end up with what is called a vector database. It is just a database full of numbers, and all of these numbers correspond to points in a space, and they all represent some piece of text, some image, something that you put in there. So again, you start to see these packs, right? So you'll see wolves, dogs, cats, cars. They are all kind of grouped together in space. This is the basic concept behind RAG. Because once we've done this with our documents, whatever we've uploaded, whatever we've embedded, we can insert a new image, right? Anyone want to take a guess at what this image might be? It's a cat, right? Because the closest things to our image in space are all cats, right? Again, what we've done is we've taken an idea. So we have images. We want to determine what a new image is. All we have to do is compare it to the other images. And this is kind of the math behind that, right? We are taking the new image and we're just finding the closest vectors to whatever we had before. That is inference, okay? To show this off and how this kind of applies to text, I'm going to go over another tool. I think you can actually hit this from a phone, so most everybody should be able to get to it. There is a tool out there called Semantle, S-E-M-A-N-T-L-E. You search that on Google, you'll see this daily word guessing game. Those of you who know what Wordle is, this is kind of the same concept, right? This game is different from Wordle. It's not a 5-letter game. It is a whatever letter game, and the goal is to determine what the word of the day is, okay? So you'll click on here, and the entire point of this is they essentially have a vector database of a ton of English words, okay? In this, these words correspond to specific vectors, right? And we are trying to find the closest word. So I can take a guess and say house, right? What it's going to do is give me a similarity. So this is either a cosine similarity or a Euclidean similarity to whatever the word of the day is, right? And it's also going to kind of round that similarity to some percentage, some hot and cold game, right? Your goal is to get there immediately, right? So if I do food, you're going to start to see I'm a little closer, but not much. 2 and 9 are really low. The word of the day will be 100%, right? You'll have 100% similarity if it is the same exact word. We're gonna let's take 5 just to play this for a while and see if anyone gets the word. I will say I know it, so if no one gets it, I'll give a little hint maybe, but you can also request a hint as well if you want, or give up if it's too difficult. If you do give up, maybe save it. Again, well, let's do like 3 minutes. I'm going to walk around, and if you have questions, feel free to ask. But yeah, let's take like 3 or 4 minutes just to play a game. It's been a negative number. Negative numbers are possible, so this is the idea of cosine. So if your angle is like all the way over here, what you'll get is a negative. You're like on the opposite side. Most of the time, you won't see super strong negatives. You'll see stronger positives than you will negatives.
So what the closeness of it is related to similarity to the thing itself?
Yeah, so like take the word husky and golden doodle.
Well, no, I understand that.
Yeah.
It's just,
It's hard. This is a hard game, by the way. This is much harder to me than Wordle is. Yeah, Wordle tends to be a lot easier than this. Again, I've played this before and done hundreds of guesses and not gotten it right, which is why, again, I'm going to cut the time at some point. But it is an interesting game. It's an interesting concept. Again, they reset it every day, so if you are one of those people that goes through like different daily games, you can go play this every day, get a different set of things. Anybody have it yet?
9.77 is the closest.
9.77?
It's the closest.
Okay, yeah. Anybody have one? I think when you get in the top 1,000, it'll actually show you like how close you are within the top 1,000. Anybody have one of those yet? No, it's a struggle bus today. It was a hard word. I will be honest, it's a hard word. Or I wouldn't say a hard word. It's not one that you would probably think of off the top of your head. We'll take maybe 2 more minutes.
I got a negative.
A negative? Yeah, you'll find a lot. When I did this earlier, I did find, I probably guessed 3 or 4 words that were all negative.
I got a 15.
A 15? Nice. Anybody have a higher similarity than that? 20? 34, there we go. You'll see at the top, it'll also tell you what the most similar word is. So in this case, it is, 65, if I'm reading that right? Which is a lot. This might have updated since I played it earlier. I feel like it was in the 50s. It might be a different worm. Take one more minute. Anybody have one in the top 1,000 yet? Okay. I will say one thing I get stuck on with this is I'll start guessing similar words. So I'll say like kitchen, and then I'll go like knife, and then I'll go carrot or something like that. And all of those are kind of in the same space, right? Like you're thinking of cooking, and then you get stuck on that train of thought. It's very hard, for me at least, to try and break that, same train of thought and go off somewhere else and guess something else. It is not the most intuitive thing, semantic similarity. Sometimes there are words that are semantically similar that you're like, I have no idea why this would be semantically similar at all. Most of the time, how they train these models, how they pull them, is just off of English text. And so semantic similarity sometimes will just come from like, hey, if you're talking about a dog and like a dog walker, right? Those are often in the same area of text, and that's sometimes how we determine semantic similarity or how we train these types of models. We'll go ahead and cut it. Anybody have a score over 35 on this? What was it? 23? Yeah, it's hard. If you don't want to see the word, close your eyes. This is about to be a spoiler. That is it. I'm not going to read it out. But that's the word. Very difficult, okay? How you get there or what you think about that is different. You can also see the nearest semantically similar words by clicking on it, okay? So it'll show you what is most semantically similar. So again, the most semantically similar had the 65.96, and you'll go all the way through there. Someone was talking about compliance training, or this is our kind of down that line, right? This is semantal. This kind of, again, the whole point of this is it's semantic similarity, right? That's the point. Anybody have questions about semantic similarity, about the game? Yes.
Really high level, how do they calculate semantic similarity?
Semantic similarity. So they're doing the same thing where it is the distance between 2 points in there. So the words are quite literally in a space. It's called a vector space, and they are just finding the distance. Or again, sometimes instead of the distance, they find the angle from the origin, right? So you can say like, oh, these are 30 degrees apart or something, and 30 degrees apart is a lot closer than 180 degrees apart, right? So you can do it that way. Cosine, I will say cosine similarity gets used, the angle thing gets used a lot more than Euclidean, where you're just finding the distance. And the reason why is because the whole two-dimensional thing, this guy is an absolute lie. What we do with these and the list of numbers we turn them into and vectors are typically hundreds of numbers long. And so we're not talking about 2 dimensions, we're talking about 768 dimensions. But 768 dimensions gets really hard to visualize after 3. So I don't know how to show it. To actually show 3 dimensions, though, there is a website called the Embedding Projector. For those of you with laptops, feel free to follow along. It's made by TensorFlow. Anyone heard of TensorFlow before? Yep, they're a coding framework, right? Not as popular as PyTorch, but along the same idea. TensorFlow is Google, I think. Google owns all of this. A lot of Google today. They do a lot of cool research. So this is with 3 dimensions. So this is 10,000 different words this data set is. So you'll see word to vec over here. That's just word to vector 10,000. And again, what you'll see is we have 10,000 points in our vector database. And this is actually an approximation visual, right? Like, again, it's not actually 3 dimensions. It's, in this case, 200, right? It'll actually tell you what the dimension of your vector database is. So different models, embedding models, there are models made explicitly for making these embeddings. They will have set dimension sizes, right? So typically what you do in a RAG workflow is, let's say you take, there's a model called embedding Gemma, right? This is an open weights model, so anybody that wants to download it, you can. Embedding Gemma is fairly new, but it is the Gemma embedding section. Gemma is the open source version of Gemini, right, which is made by Google, lots of G's. But that's what it is. I don't know what embedding model this was made with. This is just a vector database of some kind. You can actually search for words over here. They don't have all of them. Yeah, sure, 8. Sometimes you start seeing weird things, right? You'll start seeing the text actually matters more than the meaning. I will say landmark. You'll see 2 matches. There's another one in here called word2vec all. This is a list of like all English words in the Oxford Dictionary. I'm not going to click on it because 71,000 points plotting in a 3-dimensional space is a lot of computations for a web browser. But if you want to, you can. You can also add your own databases. So if there are any of you that are like coders, things like that, or doing your own AI stuff, you can actually add your own vector databases in here and visualize them. I will say I do not like the default visualization in here. I like MNIST a lot more. I don't know, for those of you who have heard of MNIST maybe. MNIST is a standard data set that is numbers, right? It's handwritten numbers. So same idea with our husky, car, cat earlier. We're just taking handwritten numbers and we're throwing them in a vector database. You can even color map these. So you can color map them by label and start to see different groups form. And then this is PCA. So essentially what this is called principal component. It's a way to take the 3 most different dimensions in that 784 and visualize those 3 dimensions, right? You basically just turn the rest, collapse the rest, and then plot them. UMAP and TSNE are typically better visualizations because what they will do is they will account for the differences in the other dimensions and basically bring it down into a 3D space. Again, this gets really hard. It doesn't show as well with words because there are a lot of words, whereas with this like image thing, we only have 10 handwritten numbers. But you'll start to see, right? You get that same idea as before. That was on the 2-dimensional PowerPoint, except this time it's with 3, right? So you'll start to see all the 2s get grouped together, 7s. You'll actually start to see where the model starts to maybe fail a little bit or where numbers start to get really similar. So 7s and 9s, right? Like if you close the loop, you start to get a 7, right? It's pretty similar. 4s and 9s, right? Some people write 4s and 9s so similar that you can't tell the difference. So you'll start to see some of those numbers bleed together. 3s, 5s, 8s. They have the same characteristics. Again, it's the same thing here. This is the same idea with semantic similarity. It's just using images, right? Same idea as before.
Do any of these views, does it show how much of the variance is being captured? Like how much you can trust this dimensionality reduction?
There is, I believe so. There was a way that I think it might be the TSNE. I'm not going to do this because it is essentially TSNE does a whole bunch of steps. It almost trains a smaller model just to do the visualization, and it takes a while. And you can do custom visualizations, but off the top of my head, I don't remember, but I feel like I did see yeah. So in the PCA, you'll see the total variance described. There you go. Just to help you get an idea of how wrong it is, I guess. But that's it.
Well, yeah, that just lets you know how much you can trust.
Yeah, exactly. More variance is not good, right? But that's it. All of these, again, are approximations. If someone wants to make a 784-dimensional visualizer, I will show it. I will use it in any time I do this again. Be my guest. It starts to get difficult, but it is the same idea, okay? Again, you can find the Euclidean distance between any of these 2 points. You can find the angle between these 2 points. Same math, you just start to scale up the number of dimensions or the number of numbers in our vector, right? This is vector embeddings. Does anyone have questions on this?
Just as a quick thought, just to confirm, from a
Yes, most of the time. Cosine, the reason a lot of people like cosine and why it can sometimes be better is oftentimes with these embedding models, the distance from the origin doesn't contain much meaning. Okay, it's more the where it is in that space. So if we go back to the UMAP thing, you'll see like where it is in the space, like, you know what I mean? I'm doing a horrible job of explaining this, but like the fact that all the ones are kind of over here and all the twos are up here is more important than the twos being closer to the origin and the ones being closer to the origin. The meaning of the words is not encoded in the magnitude of the vector. Any other questions? Yes?
So you limited yourself to 3 principal components so you could make a 3-dimensional image?
Yeah.
What information is in the 4th dimension?
You never really know. So in fact, we don't know what any of those principal components actually encode. It's the same idea as like, how does ChatGPT, when I ask it and it doesn't actually do a web search, how does it know like anything really? So how does it know how to make a pizza, right, off the top of its head?
It seems to me from my principal component work, which I've done a lot of, that it could be a 6-dimensional vector space or 8, and then the magnitude drops off significantly. So you have 2, 1, 2, 3, 6, 8, and then you have a tail, and those are the ones you can neglect because they're really small.
Yeah. It's the same idea here, and that gets into the same ideas affecting the variance and down here, right, of how off our visualization is. Because once we ignore those, non-principal components, you start to lose accuracy in your visualization, but the amount of lost accuracy typically isn't as much as the principal components, right? So it just depends. Again, most of it depends on the model. And unfortunately, that's kind of the best answer I have, is just how the model gets trained is the distribution of which components are more important or not. Any other questions? Cool. So again, we have vector embeddings as the kind of primary technology behind RAG. Let me go through this. Putting it all together, right? So how does vector embeddings help AI models take and talk to my PDF, right? That's the big thing. So there's kind of this pipeline that happens every time you ask a question to ChatGPT, to whoever else, right? What it does is it'll take your question and it'll create a vector out of it, right? It's the same idea of, taking our words that we were guessing in Semantic earlier and then making the vector out of them and then finding the distance, okay? So we take our question, we create a vector out of it, we search our database, so we find whatever is closest in our database. We combine those close things into a prompt. Once we have that prompt, we send it to a large language model, and then our large language model will give an answer, and we'll show that to the user, right? This is the typical workflow. Again, this happens without you ever knowing in ChatGPT. It happens all the time. There are some, again, this has been a big symposium on agents, right? So sometimes you'll actually have a RAG system as a tool that an agent can call. And sometimes what will happen is that this just happens by default. Because presumably when a user uploads data, we want to use that data in our context window. So sometimes we just do this automatically without the agent having to call a tool to do it, right? We just provide it in our original context and say, this is probably information you're going to want to use. Again, to kind of lay that workflow out further, user asks a question. We turn that into a vector. Again, 2 dimensions is easier to see than 784. So we do that. We put that in our user database. And then we do something called top K analysis. Okay? Top K is just a number. So in this case, I've drawn a line to the closest 5 things in our database. So this would be a top K of 5. Top K is something that most of the time whoever is making your chatbot controls. Okay, so like ChatGPT is controlling this behind the scenes. If you download offline tools or you build your own tool, you'll have to make this, or you'll have to determine this. But top K basically allows us to control how many of our document chunks actually end up in the model's context, right? So let's say you upload like 1 million different vectors in this database. Maybe we want like a top K of 20 because the most semantically similar thing might not contain our answer per se, right? Sometimes that's just because the user question doesn't exactly encapsulate the meaning of the answer they're looking for. Sometimes it's just because, again, these embedding models are statistical prediction algorithms, right? And so they end up with a statistical prediction that isn't great, right? And so we oftentimes want to increase the top K without increasing it too much as to cause the context to get bloated, right? And again, once we have our documents, so documents being these guys, these are our top K, whatever they were, our user question, we send it to the chatbot. Anyone know what I might be trying to represent with this? It's a system prompt, exactly. So again, ChatGPT has a system prompt somewhere. It's a prompt you can't change that says, hey, you're ChatGPT, you're a helpful AI assistant, right? You're going to answer the user question. Probably don't tell it that you know the user data, or there's things that they tell the chatbot to do in there that's like, don't be mean to the user, essentially, right? You don't want that. But that's it. Once we combine our system prompt, we combine our top K, our documents, our RAG retrieved objects, we send it to the chatbot, and then we actually do the generation part. To see all of this together, I showed it on a website called RAG Playground. Those of you that have laptops, you can feel free to follow along. I am going on the wrong screen. Let's see. So you can go to Google and search RAG Playground. And it's going to be this app by Vercel. So you'll see ragplay.vercel.app. Over here, it'll say interactive RAG pipeline visualization. This is a really good tool for actually seeing what RAG does. So show it off. Again, they lay out the pipeline a little differently because this pipeline is the overarching view of how this works, okay? The pipeline that I just showed was the actual context generation, right? It was the final piece when a user goes and asks a question. But before that, we have to make our database, right? We have to split all of our text. We have to turn the text into vectors. We have to do a semantic search, and then we do the rest of the steps. So you can click Start Experiment up here. And what it's going to do is it's going to give you this block of text down here. This is just a default text. You can actually, I think you can, you can paste your own text in here just to see what happens, right? But you'll see this website is split up into 3 main pieces. It's split up into the text splitting, the vector embedding, and then the response generation. The text splitting is fairly important. There's a lot that goes into this. Again, it gets more into the, hey, if I'm building an AI, how would you do that type of thing. So I'm not going to cover it too much, but you can kind of see how the actual text splitter breaks up chunks. You have a question? Just stretching. All good. Yeah, so our text splitter will go in and it'll actually break up chunks. Oftentimes we break up chunks by, we try and keep paragraphs together. Sometimes they contain relevant information, right? We assume a paragraph might contain all the same kind of information. You can actually set a chunk size and an overlap size. This overlap helps us keep context the same between chunks, right? So if we end up breaking in the middle of a sentence or breaking in the middle of a paragraph, we want an overlap, right? So we have idea of where the thought was going and where the thought came from. This method is called recursive character. It just means it counts 500. It'll break on certain characters. I think they're called ligatures, maybe. Separators is what they're calling them. This just means it's going to break on, a new line or a period, right, in a sentence, something like that. So we look for that to break There are different strategies as well. There's this thing called fixed character. This will do no overlap. So recursive will give you an overlap. It's typically better if you do have like a ChatGPT or a website like that. It's using recursive character text splitting more than likely. Fixed character, again, you start to lose context between your chunks, and that's not good. Again, the same idea. You have 500, and it'll generate these exact chunks. There's also another strategy in here that I have not seen very often. Way less common. It's called parent-child. Essentially, you break it up into very big blocks of data, and then you break those big blocks into smaller blocks. And then when you go and do the retrieval in a parent-child, what you can do is you can pull all the text in the parent rather than just pulling the child, and that can give your model more context to look at, and it's sometimes helpful. Again, I've seen this less common. It's more of an expensive process to do this. But it does exist. There's another one that is more on the kind of cutting edge of RAG research right now called late chunking. Anyone's heard of that? Late chunking changes it all entirely. Essentially, instead of going from text splitting and then embedding all of the split chunks, you almost embed the entire thing, and then based on the embedding results, you change how you chunk your data. It can give you a lot more semantically similar chunks, right? Because again, you've done an embedding process first. The problem is it takes forever, right? Oftentimes you don't see it, but again, it's one of those research things. Kind of cool. After we have chunked our data, I'm going to go back to recursive character. We do vector, or actually any questions about text splitting first? It's fairly, I think fairly simple, right? You're just cutting the text up into blocks. Anyone have an idea of why you might not want to just throw the whole thing as a vector? Yeah, it's a lot. It's encoding a lot of information, right? So if we're representing this entire thing as 784 numbers, you start to lose the actual meaning in that, right? You can't encode all of the information into one vector, so you break it up. Images, it's a little easier, right? Because images are only representing a certain number of things. It's a little different. You can have vector databases that are made from images, some that are made from text. Sometimes you can take an image, you can caption the image, so essentially convert the image into a textual description, and then you can embed that textual description to get an image embedded in a text database. And sometimes that's how ChatGPT or whoever else will actually search images, is they are actually generating a caption of the image, and then they are searching the caption, right? Because text and then image data don't mix, right? You have two different modalities, they're not the same. Vector embeddings and similarity. So you'll actually see what this website does is it loads an embedding model inside of your browser. Again, these are specific models to do embedding. If you go to a website like Ollama, for those of you who don't know what Ollama is, it's a tool by Meta that allows you to host your own models. So download them to your own laptop. It's very good. Used in a lot of things. You can search for explicitly embedding models, and you can see some open source embedding models. So embedding Gemma, right? I talked about that one earlier. You'll see Quinn 3 embedding. I haven't tried that one yet, but I will say Quinn 3 is fairly impressive if you're running an offline LLM. Nomic embed text. This guy is a classic. This guy is used pretty much everywhere. It's a really, really good text embedding model. And then they have this newer one called V2 that I have not tried. That is an embedding model. Again, we use that to convert our text into numbers. It is just a specific model to do that thing. And then at this point, we can ask a question. What is the RAG? Isn't a great question. We can say, what is RAG, right? And then what you'll see is RAG Playground will actually do the same thing that we were doing earlier, and it'll make a projection in 2 dimensions out of what's happening, right? So this is like the thing where the cat, the car, everything else we're plotting, except this time it's actually doing it in a real RAG workflow. You'll see it also does your top K, right? So you'll see it draws a line to the closest vectors. This is a top K of 5, right? It's drawing a line to the 5 nearest things. So what you'll see is it finds all your chunks, and it will sort them by semantic similarity. And you'll actually see the raw vector. So this is the actual list of numbers. They don't show you all of it because, again, it's 384 numbers, and they don't really mean anything just looking at numbers, right? But what you can do is you can take those chunks and then their embeddings, and then you correspond the two, and then all of a sudden you have a list of what the most similar data in whatever file, whatever you're looking at is. So you'll see our question was, what is RAG? The most similar chunk out of our text is, what is retrieval-augmented generation? Shocker, right? It's almost the same thing. You'll see a 0.79 similarity. That's fairly high. And then you also get the paragraph below this, which is the description of RAG. So again, like I was saying in the beginning, RAG, the whole point is to get better answers. Models on their own kind of suck. We're in a data regime right now, right? Data kind of rules all, because good data processed by an OK LLM still gives a good output, right? Data is really the controlling factor in how good your answer is. That's why models do web search, right? When you ask ChatGPT a question, normally it goes and searches the web, right? Because the web probably has an accurate answer versus ChatGPT essentially trying to remember what the answer is. The comparison I always make it to is I think of models like third graders, right? But this is like essentially you've given a third grader like the largest library in the world, and all the time they want, within a second, they can go read any book and give you an answer, right? So a third grader on its own, not that great, but when it's got an entire library, right, and all of time, you have pretty good answers. Again, once it goes through and does this, the last step is response generation. So at this point, you're actually going to see that part we were talking about earlier, where it combines all the things and sends it to the LLM. So you'll actually see up here at the top this "you are a helpful assistant." Anybody know what that is? We talked about it. System prompt. Yeah, that is your system prompt. Oftentimes, you will actually see this pretty much verbatim, this line here. If you don't know the answer, just say that you don't know. Don't try and make up an answer. You have to tell the chatbot this, OK? Otherwise, it will try and pull something out of its memory, and that's when you get hallucinations, right? That's when things start to be wrong, OK? If you are designing a RAG agent and you're really wanting your model not to hallucinate, not to do that, this is helpful. As crazy as it is to tell somebody to not, make up an answer, it actually helps. And then you'll start to see what we do is we just insert all of our context. So we take our most similar chunks and we put them in as context. So you'll see that this is just the straight text that we embedded earlier, right? And we put that in as a line of context. And then at the bottom, we put in our user message. Again, the beautiful part about all of this is that we have essentially given the model a user question, and then right above that user question is the exact answer the user wants to know, OK? This is just a lot faster than Google, is essentially what it is, right? Like Google has this answer somewhere, but what happens is when we can give an AI model, right, whatever the exact answer is from Google or wherever else, and then we give it a user question, the AI can synthesize that information and give it to a user a lot faster than, hey, I'm going to go click on this web page, this web page, this web page, right? It's information retrieval. And then after this, you can do generate response. And it's going to give you an answer that is summarized from whatever was in its context. And that's how we get better answers as a chatbot, essentially. Are there any questions on RAG Playground, what RAG is, all of that? Any questions at all over stuff I've talked about? Hopefully this is fairly interesting. Again, it's more or less this is what is happening behind the scenes when you upload a document. I think on a day-to-day, again, if you have not used Notebook LM, just try it. Honestly, try it. If you are a government guy and you have unclassed documents, you can throw them in here, and it's great for it. There are actually things in here to generate briefs on information. Super helpful.
What libraries would you recommend to create a
RAG pipeline. So typically what I'll do is you have to have, your database can't just be any database. Typically, like with SQL, right, you have a structured database. With vector embeddings, they're not actually structured. So you have to have an unstructured database of some kind. The one that I use most commonly is called Milvis. Milvis is really good. You can host Milvis as its own like database server, or Milvis also has an embedded version. It's called Milvis Lite, where if you're making a small application on your own and you just need a tiny little vector database somewhere, it'll actually store the database as a single file, and you don't have to worry about a ton of setup. Very easy. Outside of that, if you want to do offline RAG, anything LLM will let you do that. I kind of talked about that earlier. I'll actually see, I think I can show it off. Anything LLM kind of does all the pieces of like what you would want offline, but you don't have to code it, which is great, right? But anything LLM ends up looking a lot like a ChatGPT would, or something like that. But you just separate your workspaces up, and then you can have questions like, what is the capital of Alabama, right? There are ways to do web search in here. These searches are really old. I will say anything LLM's gotten a lot better since I've used it last. Most of what I do is online or tools that I've built internally. So I don't use it as much. But for an offline tool, it's very good. It'll even work with reasoning models. It'll work with a bunch of other stuff. That kind of answer your question? Yep.
In terms of model selection, you went through a couple of them, especially if you're building offline. What considerations do you have for parameters?
With embedding models, it is really easy to, it really, truthfully, this is a bad answer, it doesn't matter. Embedding models are minuscule, okay? Like LLMs are huge, but the actual embedding model is tiny. What you're starting to see now that I found really interesting is a lot of IoT sensors will actually include an embedding model on them. And then what you do is you take your sensor data, you embed it, and then you send it back to whatever your server is, right? And your server does the LLM processing at that point. But embedding models are light enough to run on an IoT device like a microcontroller or something else. So very, very low weight. Again, nomic embed text is typically been my go-to. I've heard a lot of really good things about embedding Gemma, though. Gemini, right now, for those of you who don't know, is like dominating the El Marino leaderboard just because the model itself is so good. I don't really like Gemini's actual tooling interface, so sometimes I find better answers elsewhere. But the model itself is really good. So anything, again, embedding Gemma comes from the Gemini architecture, so just to give you some sort of context on that. Any other questions, comments, concerns? Want to go back to the AI podcast and talk to it for a while, maybe. I don't know.
Yeah, I got one.
Yeah.
So yesterday we learned a lot about sub-agents and skills.
Mm-hmm.
When, I guess, is there some context you could give around when you would want to use the sub-agent, the skill, or just play around with the RAG system?
Yeah, so in a fully agentic system, there are a lot of considerations, and the kind of bad short answer, or it's kind of the best answer, is it depends on whatever the application you're building is and is intended for. So like I said before, with like a ChatGPT, for example, when you have that, ChatGPT is an agent, right? It has tools it can call. But typically, like if a user uploads a document to ChatGPT, we can fairly reasonably assume that the user is probably going to ask questions about that document, right? And so RAG at this point doesn't actually become a tool. It just happens before the model or the agent ever gets run. And that way, the first time that model runs, it has context that the user wants, right? You can do it like that. I've also set it up as a tool. I will say, when you set it up as a tool, there's a lot of considerations in how you have to label the tool, how you have to define the workflow, right? Your system prompts in your agents start to matter a lot more, especially if you want that tool to be called often. You start to get finicky. Again, these are statistical prediction algorithms. So most of the time when I'm trying to code these out, I'm actually putting as much in hard-coded as I can and then leaving fairly little to the model itself, other than like, starting to get into the tool calling piece where it's like, depending on the question, you might need this or that. But when you upload a document, right, typically you're always going to want some relevant context to that document. So depends on the application.
When you're saying hard coding for the tools, you're talking about in the system prompt? Like you're changing the system prompt?
Yeah, it is effectively, RAG is almost effectively changing the system prompt. It's not called that, but it's just passing in the data as context, right? So it's something, again, as a user, you don't see the chunks that get pulled from the vector embedding, but it does happen. It just happens behind the scenes. So, any other questions? I will stick around for 10 minutes. Again, I was shooting to be done by 1 just so people could go eat. So I hope you appreciate that. I will stick around for the next 10 to 15 minutes. If anyone has questions, you're welcome to stick around. Again, this has been RAG Revolution. If you're interested in more of what we do, again, training, talks, we do R&D, contractors, all that kind of good stuff, the Huntsville stuff. So that's what we're here for. In terms of courses, we do long-form continuing development, right? So any of these courses, you'll see the ones that are labeled as 3 days are up there, but most of these are actual 5-day sit-down courses. So again, most of these are geared for government customers. Specifically, you'll see a lot on TSCM. It's kind of our primary focus, but we do have AI Essentials 3-day and 5-day, and those are more or less AI applications, and we go into a lot of the offline pieces, like how you would actually implement this offline, and that way you can do it at your own system, right? That is all I have. Again, I will stick around. Thank you for coming. If you have further questions, here's my email. Thank you.